Pluto, once the ninth planet of our solar system and now classified as a dwarf planet, has captivated astronomers and space enthusiasts for decades. From its discovery in 1930 to the groundbreaking images sent back by NASA's New Horizons mission in 2015, Pluto remains one of the most mysterious and intriguing celestial bodies in our solar system. Despite its small size and distance from the Sun, this icy world is packed with fascinating features, from towering mountains made of water ice to vast plains of frozen nitrogen. Scientists have uncovered surprising details about its thin atmosphere, potential underground ocean, and even the possibility of cryovolcanism, volcanoes that spew ice instead of lava. Pluto's story begins in the early 20th century, when astronomers noticed small gravitational discrepancies in the orbits of Uranus and Neptune. These irregularities hinted at the existence of a ninth planet. In 1930, Clyde Tombaugh, a young astronomer at the Lowell Observatory in Arizona, discovered Pluto by painstakingly comparing photographic plates taken on different nights. At the time, it was believed to be a planet, but its small size and unusual orbit soon raised questions about its true nature. Unlike the 8 major planets, Pluto's orbit is highly elliptical, sometimes bringing it closer to the Sun than Neptune. It also follows a tilted path, deviating significantly from the nearly flat plane in which the other planets orbit. These characteristics suggested that Pluto might be something different, perhaps part of a larger population of icy objects beyond Neptune. That idea gained support in the 1990s when astronomers discovered the Kuiper belt, a vast region filled with thousands of small, icy bodies. Pluto was no longer alone. It was simply the largest known object in a new class of celestial bodies. This led to a historic decision by the International Astronomical Union in 2006. Pluto was reclassified as a dwarf planet, a move that sparked controversy and debate among scientists and the public alike. Despite its demotion, Pluto remains one of the most studied objects in the outer solar system. Its surface is a mix of frozen nitrogen, methane, and carbon monoxide, creating a reflective and dynamic landscape. The most famous region is Sputnik Planitia, a vast, smooth plain of nitrogen ice that appears to be geologically active. Surrounding this area are towering mountains made of water ice, which is strong enough to support enormous structures in Pluto's frigid temperatures. Perhaps even more surprising is Pluto's atmosphere. Although extremely thin, it contains layers of haze that stretch hundreds of miles above the surface. This haze is created when ultraviolet light from the Sun interacts with methane, producing complex hydrocarbons that slowly drift downward and settle as reddish material on the surface. Unlike most planetary atmospheres, which are stable, Pluto's atmosphere undergoes dramatic changes as it orbits the Sun. When Pluto moves closer to the Sun, its surface ices sublimate, creating a temporary atmosphere that freezes back onto the surface when Pluto moves farther away. One of the biggest mysteries surrounding Pluto is the possibility of an underground ocean. While scientists once thought Pluto was completely frozen solid, data from New Horizons suggests otherwise. Some surface features, such as fractures and ridges, hint at a subsurface layer of liquid water that might still exist beneath the thick ice shell. If confirmed, this would raise exciting questions about the potential for life in one of the most unexpected places in the solar system. Another surprising discovery from New Horizons was evidence of possible cryovolcanism, volcanoes that erupt with icy slush instead of molten rock. Large domes and flow-like structures on Pluto's surface suggest that at some point in its history, internal heat may have allowed liquid or semi-liquid materials to reach the surface. If cryovolcanism is active today, it could provide further evidence of a subsurface ocean. Pluto isn't alone in its journey around the Sun. It has 5 known moons, the largest of which is Charon. Nearly half the size of Pluto itself, Charon is so massive that the two bodies actually orbit a common center of gravity outside of Pluto, making them more of a binary system than a typical planet-moon pair. Charon's surface is covered in water ice, with deep chasms and cliffs hinting at a violent past. The other four moons, Styx, Nix, Kerberos, and Hydra, are much smaller and irregularly shaped, likely formed from debris after a massive collision billions of years ago. Despite being demoted to a dwarf planet, Pluto continues to captivate scientists, offering insights into the early solar system, planetary geology, and the potential for life in extreme environments. The discoveries made by New Horizons have reshaped our understanding of this distant world, proving that even the smallest and most overlooked celestial bodies can hold incredible secrets. Pluto's story isn't over. Future missions may one day return to this icy world, bringing more advanced instruments capable of answering lingering questions. Could there be an active subsurface ocean? Is cryovolcanism still shaping its surface? And what other surprises does Pluto have in store? As technology advances, humanity's exploration of the solar system will continue to push the boundaries of what we know, ensuring that Pluto remains a fascinating subject of study for generations to come. Pluto's place in our understanding of the solar system has evolved dramatically over the decades. Once thought to be an isolated oddity at the edge of the planetary lineup, it is now recognized as one of the largest members of the Kuiper belt, a vast region of icy bodies beyond Neptune. This shift in perspective has led scientists to reconsider not just Pluto itself, but the entire structure and formation of our solar system. One of the biggest revelations from the New Horizons mission was the diversity of Pluto's surface. Unlike many celestial bodies in the outer solar system, which are heavily cratered and geologically inactive, Pluto's landscape shows signs of constant change. The smooth plains of Sputnik Planitia, for example, suggest that Pluto's icy surface is renewed through convection, where heat from beneath causes nitrogen ice to slowly churn and refresh itself. This process, similar to the movement of magma within Earth's mantle, means that Pluto is far from a dead world. Pluto's mountains, composed largely of water ice, are another surprising feature. On Earth, water ice is relatively soft, but in Pluto's frigid temperatures, hovering around negative 375 degrees Fahrenheit, it becomes as hard as rock. Some of these mountains, such as the Tenzing Montes, rise as high as 11,000 feet, comparable to the tallest peaks in the Rocky Mountains. This discovery suggests that Pluto has experienced tectonic activity, possibly driven by the slow freezing and expansion of a subsurface ocean. Another intriguing feature of Pluto's landscape is its network of valleys and ridges. Some of these formations stretch for hundreds of miles, cutting across the dwarf planet's surface. Scientists believe they may be the result of past or present geological processes, such as the slow contraction or expansion of Pluto's icy crust. These features provide important clues about the planet's internal structure and how it has evolved over billions of years. Perhaps one of the most surprising findings from New Horizons was the color of Pluto's surface. While many expected it to be a uniform icy white, Pluto instead displays a range of reddish-brown and dark patches. These colors are the result of tholins, complex organic molecules that form when ultraviolet light from the sun interacts with methane in Pluto's atmosphere. As these molecules settle on the surface, they create Pluto's distinctive reddish hues. The presence of tholins is particularly intriguing because they are considered key ingredients in the chemistry that leads to life, raising fascinating questions about Pluto's potential for prebiotic chemistry. The thin atmosphere of Pluto adds another layer of complexity to its environment. Composed primarily of nitrogen, with small amounts of methane and carbon monoxide, this atmosphere is unique in that it expands and contracts significantly over Pluto's 248-year orbit around the Sun. When Pluto is closer to the Sun, some of its frozen surface sublimates, creating a transient atmosphere that is gradually lost to space. As Pluto moves farther from the Sun, the atmosphere refreezes, falling back to the surface as frost. One of the most striking atmospheric phenomena observed by New Horizons was Pluto's blue haze layers. These layers, extending up to 200 kilometers above the surface, scatter sunlight in a way that resembles the blue sky on Earth. This effect is caused by tiny particles suspended in the atmosphere, which further contribute to the reddish tint of Pluto's surface as they settle. Pluto's relationship with its largest moon, Charon, is unlike any other in the solar system. Because Charon is so large relative to Pluto, the two bodies orbit a common center of gravity located outside Pluto itself. This makes Pluto-Charon more of a double dwarf planet system than a traditional planet-moon pair. Charon's surface is just as intriguing as Pluto's. It features massive canyons, some of which are deeper than the Grand Canyon, as well as a vast dark region near its north pole known as Mordor Macula. Scientists believe this dark area may be made of materials that have migrated from Pluto's atmosphere, settling on Charon's surface over time. Unlike Pluto, which has an atmosphere and an active surface, Charon appears to be geologically dead, with little evidence of recent activity. However, cracks and fractures in its crust suggest that it may have once harbored an internal ocean that has since frozen solid. The other moons of Pluto, Styx, Nix, Kerberos, and Hydra, are much smaller and more irregularly shaped. These moons are thought to have formed from the debris of a massive collision that created the Pluto-Charon system billions of years ago. Interestingly, these smaller moons rotate chaotically, tumbling unpredictably as they orbit Pluto. This is likely due to the complex gravitational interactions within the Pluto-Charon system, making their motion unlike anything seen elsewhere in the solar system. The discovery and study of Pluto have had profound implications for our understanding of planetary science. When Pluto was first reclassified as a dwarf planet in 2006, the decision was met with strong public and scientific debate. However, this reclassification was not meant to diminish Pluto's importance, but rather to refine how astronomers define planets in light of new discoveries. The Kuiper belt, where Pluto resides, is now known to contain many other objects similar in size and composition, including Eris, Makemake, and Haumea. This has led scientists to reconsider what it truly means to be a planet and how our solar system formed. Looking ahead, Pluto remains an object of great scientific interest. While the New Horizons mission provided an unprecedented glimpse into its world, many questions remain unanswered. Could there still be liquid water beneath its surface? What drives its geological activity? And what can Pluto teach us about the outer solar system's history? Future missions to Pluto and the Kuiper belt are already being discussed. Some scientists propose sending an orbiter to Pluto that could study its surface and atmosphere in detail over an extended period. Others suggest exploring the Kuiper belt further, searching for more objects like Pluto to better understand the diversity of icy worlds in the outer solar system. Despite being over 3.6 billion miles from Earth, Pluto continues to captivate scientists and the public alike. It represents the outer frontier of our solar system, a world of ice, mystery, and surprising activity. Whether classified as a planet or a dwarf planet, Pluto has proven itself to be a dynamic and fascinating world, reshaping our understanding of the solar system and challenging our expectations about what a small, icy body can be. With each new discovery, Pluto reminds us that the universe is full of surprises, and there is still so much left to explore. The more we learn about this distant world, the more we realize just how little we know about the farthest reaches of our own solar system. One of the most exciting aspects of Pluto's study is the possibility that it could harbor a subsurface ocean. While Pluto was once thought to be a frozen, geologically dead world, evidence from the New Horizons mission suggests otherwise. The presence of fault lines, ridges, and even potential cryovolcanoes indicates that Pluto's interior may still hold liquid water beneath its thick, icy crust. Scientists believe that if a subsurface ocean exists, it could be kept from freezing by residual heat from Pluto's formation, radioactive decay within its core, or even the presence of antifreeze-like compounds such as ammonia. If this ocean remains liquid, it would place Pluto among an intriguing group of icy worlds, including Europa, Enceladus, and Titan, that may have environments capable of supporting life. The idea of habitability on Pluto is, of course, highly speculative. With surface temperatures that plunge hundreds of degrees below freezing, any life that might exist would have to survive in extreme conditions. However, life on Earth has been found in some of the most inhospitable places imaginable, such as deep-sea hydrothermal vents and subglacial lakes in Antarctica. If Pluto has a subsurface ocean, it raises the question, could microbial life be hiding beneath its icy shell? Pluto's surface also shows evidence of ice flows, which suggests that material from the interior has moved and reshaped the landscape. Unlike Earth's plate tectonics, which are driven by the movement of rock, Pluto's geological activity appears to be powered by the slow movement of nitrogen, methane, and water ice. Sputnik Planitia, the massive nitrogen ice plain, is one of the most dynamic regions, with evidence that the ice there is constantly shifting and renewing itself over time. Adding to the mystery, Pluto's relatively young surface age presents a puzzle. If Pluto were an old and inactive world, it should be covered in craters from billions of years of impacts. However, some areas, especially Sputnik Planitia, show very few craters, suggesting that they are geologically young and still changing. This is a significant discovery because it means Pluto has an internal energy source capable of reshaping its surface, even billions of miles from the Sun. Another fascinating aspect of Pluto's system is its chaotic and unpredictable nature. Unlike the planets in our solar system, which have relatively stable rotations and orbits, Pluto's small moons tumble unpredictably due to the gravitational influence of Charon. This makes Pluto's system one of the most dynamic and complex in the solar system. Beyond Pluto, the Kuiper belt itself is a region of ongoing discovery. Pluto was once thought to be a lone oddity, but now it is understood as just one of many large icy bodies in this distant region. The discovery of similar-sized objects like Eris, which led to Pluto's reclassification as a dwarf planet, showed that the outer solar system is far more diverse than previously imagined. The Kuiper belt extends for billions of miles beyond Neptune, containing countless icy bodies that hold clues to the early formation of the solar system. Because these objects have remained largely unchanged for billions of years, they are considered time capsules that can provide insight into how the solar system evolved. The New Horizons spacecraft didn't stop at Pluto. After its historic flyby, it continued deeper into the Kuiper belt and visited another object, Arrokoth, in 2019. This distant snowman-shaped world is believed to be one of the most primitive objects ever studied, providing scientists with a glimpse into the building blocks of planets and moons. The study of Arrokoth has strengthened the idea that Kuiper belt objects are remnants from the early solar system frozen in time. Future missions could explore Pluto and its surroundings in greater detail. Scientists have proposed sending an orbiter to Pluto that would spend years studying its atmosphere, surface, and interior. Unlike New Horizons, which provided only a brief snapshot, an orbiter could observe seasonal changes and reveal how Pluto evolves over time. Another proposed mission involves sending a lander to Pluto's surface, equipped with instruments to analyze its ice composition, search for signs of a subsurface ocean, and study atmospheric interactions. The challenge, of course, is the extreme distance. Any mission to Pluto requires careful planning and decades of travel time. Even if it takes years to return, the fascination with Pluto is unlikely to fade. The distant world has defied expectations at every turn, showing that even the coldest and most remote corners of our solar system can be dynamic, active, and full of surprises. Pluto's legacy extends beyond its scientific importance. Its story, discovered as a lonely ninth planet, then redefined as part of a vast new frontier, reflects the evolving nature of space exploration. As technology advances and new missions venture into the unknown, Pluto will remain a symbol of curiosity, discovery, and the endless quest to understand our place in the universe. Pluto is not just a frozen rock at the edge of the solar system. It's a world of mystery, wonder, and scientific intrigue. And as our exploration continues, it's only a matter of time before we uncover even more secrets hidden in the depths of space.